everyone doing the awesome day of FileMaker training. We are here the week of Christmas or week into Christmas, whatever we want to call that. And so Margaret is running the broadcast studio. I'm here in the Santa Clara office meeting with my team and preparing for the upcoming FileMaker certification training. A lot of you are not aware of this. You haven't been paying attention. But if you have our current subscription to our complete bundle, a bunch of you have that. We really appreciate it. A, you're helping to pay the bills to keep the live streams running. But more importantly, we have new Azure training, how to do single sign-on and Active Directory with that. That's part of your training. Additionally, we have upcoming a live multi-day event. Won't be at 1 o'clock. 1 o'clock continues to be kind of our free live stream that we do. But 2 hours prior to this, 11 o'clock Pacific time, 11 o'clock a.m. Pacific time, we will be doing about 90 minutes a day of doing certification training. And the goal is to get you through getting certified. And if you've had problems getting certified, you got close, you didn't quite make it, or you're kind of scared to even try it, it's the place for you to come and hang out because we are going to spend time focused on that. The time won't be about building a better FileMaker that's faster and it's more beautiful and it's not an abomination and it's going to scramble your ravioli. Just shelve all that. This is about passing the test is what this is about, right? So that's what we're going to be doing. So if you go to fmtraining.tv, what you can do, scroll over here. That's our live stream. This is the upcoming broadcast for this coming week. And you can see more SQL action today with Kyle Williams. Pretty cool. Tomorrow, some Keziman action. Then we got Nick Hunter on Wednesday and Thursday. There's nothing on Christmas. We have a little box here to tell you, nothing here, right? No live stream. If you're on our website, fmtrain.tv, you come down here and you come over here and you actually hit refresh. On the right side, it says certification training. You click on that. This is our special high-intensity training for FileMaker certification. Some of you are smiling to yourselves. Yes, that was deliberate. Yes, so we are going to be doing training on January 10th, 11th, 12th, 13th, 14th, and probably, frankly, a big chunk of the week after in the same time spot. It's going to be recorded. It's if you actually have our complete FileMaker training bundle, then you get to come to this totally free. If you want to come to this and you don't have our bundle, go get the bundle. Some of you really don't want to have the training bundle, but you want to come to this. If that is you, you're like kind of that like minority of people. Like we hate the training, but we want to come to the certification training. We don't want all the other benefits. You can click right here and buy the specialized FileMaker certification training by itself right there. So no big deal. Or you can come up here and buy the complete bundle and get the certification training too. So whichever way floats your boat, totally good. We have a bunch of people who've been buying into this, signing into this. Welcome all of you aboard. Some of you are going to expire. Please renew, right? Really appreciate it. So awesome stuff that's coming in. Kyle Williams, are you ready to take over?
I'm ready. I'm here.
Kyle, you're
all right. So today we're going to discuss a little bit more SQL, but we're also going to discuss how we can get our result back in JSON format. So I'm going to go ahead and share my screen so we can get started here. And we'll get this out of the way. All right, so this is day 3 of 4 on this. And today we're going to discuss creating JSON from your SQL response. So the first question with this is, how do we do that? How do we get our response to come back in the SQL format? So I have here a little simple formula. I'm going to go ahead and color code it. And so we have JSON format elements. And what we have here is we have an SQL statement here. And so really kind of need to break this down so you understand what's going on. So there's, I explained in the past few weeks that you can concatenate your result in FileMaker. You can concatenate this, in ExecuteSQL. So we have our select statement, and then we have the curly brace to start our JSON. And then I have these placeholders. So this is a placeholder for a quote. So right here would be our key. So this is our key for name last. And then we have our colon, which is our separator. So there's space and a colon and a space. And then we have our value is right here. So this is concatenating our last name field with these double pipes and then a quote on either side of it from, and then our end curly brace from our contacts table. And then it goes down here. So we have it's an array, so it's going to return an array. So we have our square bracket there and our end square bracket here. And then we're going to do some escaping. Because sometimes when you have a field in here, it's going to have some quotes in it, or it might have some backslashes or some other stuff that we got to get rid of. And then here we're going to put our quotes in at the end after we're done escaping everything. So this is just a very basic example of how this works. So when I hit run, it's going to go through this. It's going to add all the curly braces in here. It's going to add the little comma. It's going to add the value here, or the key, I mean. So it's going to add the key with the quotes on either side. And just like you see right here, it's got all the stuff from here down to here. It's all concatenated over here. So we could pull this apart a little bit in the data viewer so you can get kind of a better idea of what's going on here. And let me just delete all of that. Okay, start fresh. So here we have this, and let's go ahead and remove the format, remove this, and let's see, let's do evaluate. So we can kind of see what's going on before it formats it. That's what we're actually getting back as a result. So this top brace, so I'm kind of going backwards here. Substitute, okay. So that'll get rid of the brace at the top. So it's kind of backwards engineering here. Okay, so what do we got going on here? We got our substitute here. We got our ExecuteSQL call, which is getting all of our last names from our contacts table. But what we're doing here is we're adding all of this to our response. So that's all this stuff at the beginning. We want to add that into our response. I apologize for the phone going off. Okay, so we're adding this into our response, and then we're also adding this at the end. So we got our curly brace right here, our quote, all of that's at the end. Our comma is actually from the SQL. So right here we have a default. That's our field separator, or record separator, sorry. No, that's a field separator. This is a record separator. So to separate the records, each line is its own record. So our record separator, instead of just doing the return carriage, we're doing a comma return carriage. And that's what's giving us this and the return carriage to the next line. So hopefully that starts to make sense. And then we're just adding some extra stuff to it. So you can see over here, we added the bracket at the start and at the end, and then we're throwing all the stuff in there. So if I were to take all the substitute stuff out, it's going to look really weird. So that should still work. This box is a little bigger than I thought it would be. So yeah, that looks really weird, huh? So that's before all the substitutions, just so you can see what the raw value is. So really kind of cool looking, actually, with all the Unicode character there. I'm using Unicode Q there because, that's something that pretty much nobody ever uses. So when you got to do a substitute like that, you want to use something that nobody's ever going to use in their field, or very unlikely they would ever use that. So you don't want it to ever break. So that's basically how this works. So let's see what's yeah, or even put a picture of the phone on there. I apologize for the phone. That's really annoying. But my work, it's in an office. What can you do? All right, so I'm just going to colorize this so we can see it a little better. So here's the introduction to creating JSON from ExecuteSQL. So this welcomes a whole new world of possibilities. And right from the beginning, when we first got the JSON functions in FileMaker 16, this was a huge deal because we were already starting to use JSON. Everybody was starting to learn it. And then we got the ExecuteSQL function, we got that in 12. So the JSON functions came in 16. So we had the ExecuteSQL, and it always returned us a list of stuff. And we're like, how can we better leverage this? How can we, how can we look at it and know exactly what everything is? So basically, this is combining several functions here. So I outline the syntax of each of the functions that's going on here. So this is JSON SQL select, and that is for this whole top group here. And it starts with a list of all the fields that we want. So this is using this function to with 3 parameters. So we got our JSON path, our field reference, and the data type. The data type is optional. It'll guess what data type it is, but this could be JSON string, JSON number, JSON Boolean, and so on. So you can use this kind of cast it as a different field type if you wanted. So that's kind of handy. So I'm just going to run this so you can see what this looks like. So like for here, I could change this to JSON string. And all of these IDs suddenly become a string. So it's going to use the value, it's going to look at this field, and it's going to evaluate if this is a number field, if it's a text field, and it'll automatically choose what kind of JSON type from the field type. And then down here we have our list. So this is where our from and where statements come in. And then we have our result. This last function, sorry, it's kind of weird working with the text field instead of a data viewer. So JSON SQL result, you can see down here is basically just taking the result, this JSON result, and you can decide if you want this to be formatted or not. So if I type false or do a 0 here, then you get unformatted JSON. Alternatively, you can do a 1. So basically true or false. So I can type false there, and it'll unformat it. So personally, I like to just keep a 1 there, or true, because I like things to be formatted nice and pretty like that. Looking forward to a few substitutes to produce JSON from. Okay. Sorry, I was reading a comment there. Okay, so where do we want to go next? Oh, yeah. Okay, so that's what I was going to do. I forgot what I was going to do next there for a moment. Okay, so I'm just going to do this real quick, and we're going to go back into the data viewer. So I wanted to show you how we can modify this in order to get a different kind of JSON response. So right now, oh, I have a comment in there. Okay, so I'm just going to turn this automatic evaluate on for a moment. So right here, we're going to go ahead and extend this a little bit. So I can add as many fields here as I want. And so instead of first name, maybe we're just going to do name.last. And you can see already this is creating a new JSON object within our JSON. So I can also do, apologize, I just noticed this. First, last. Okay. So I'm going to turn that off for just a moment. Just so let's say address dot. I like to keep this consistent, so I'm just going to lowercase that. Okay. Copy. Bear with me here for just a moment while I do this part. Okay, so street. Actually, we want city first, right? City. Zip. So copy. And zip. Okay. So basically what this is going to do is it's going to allow us to be able to put all the address in one little object. We can put the name in another object. We can also do email and phone number, and each of those can have their own object. So what we can do here is we can really put a lot of things together, and we can build this out. And you can actually add as many extensions here as you want. So if I just started adding things like that, and then I did evaluate, you can see it'll build the array to whatever dimensions you want. So you can make it as deep as you want, or I'm just going to go ahead and remove that. But just for example, you can create any kind of JSON you want. So super powerful, especially when you're working with APIs and stuff. APIs always want things formatted specifically a certain way. And if things aren't in the right spot or right order, then they can break. So basically, that's how you can use it. So I introduced these functions before, but for those that didn't watch the previous videos, SQLT is getting the table out of this, and SQLF is getting the field out of it. And it's returning it in quotes. So that's why it's got SQL in front of it. It's because it's going to take apart this here and do contacts in quotes for the T and ID contacts in quotes for the F. So that way it doesn't break in case there's a space or a pipe or some other character in there. You don't want anything breaking. So everything is sourced dynamically, so it'll never break. So this I was just kind of putting in here. I want to just make sure I was catching everything. So yeah, the last one I did, I'm going to copy and we'll go to the data viewer for this part. All right, so basically I wanted to show you that you can have the date here, the time, timestamp, and you can get it as either UTC or you can get it formatted as a FileMaker timestamp. So here we have the UTC, and you'll notice the difference between UTC and the FileMaker section is we're adding JSON string to it. So just simply by changing the object type, the data type, we can get it to go from this UTC date and timestamp format into a FileMaker acceptable date and timestamp. So that way you don't have to use any custom functions to convert this. You can plug it straight into your scripts without having to deal with that. So I figured that would be really helpful. Another thing I forgot to mention is this right here, this very first parameter. That's what allows us to index this. So that way we can do a JSON get element and we can put in our record ID to get the record by its ID. So basically it's indexing all of this. So we're getting 501 or 50105, 50106. So it indexes it also. We don't have to worry about that. So if I were to clear that out and evaluate it, go to the top, you can see it's no longer indexed. So you can also add that ID down here as well, but it's really good to have the option here. So I'm just going to go ahead and put that back. And just so you can see, just like that, it added that in there, indexed everything. So really helpful to know that you can do that. Apologize, I didn't title this or put a description in there. I just added that this morning. So I wanted to make sure that I didn't forget that these format issues or the being able to index it with the ID right there. So when it comes to getting your row ID and your row modification ID, so this is like your record ID or your record modification ID, what we're doing here is we're creating some variables right at the start. So we're just going to call these custom expression 1 and 2. And so you notice right here is where I had the field before, and this is where we had the JSON string, JSON number. So that's our data type. So in order to be able to create customized concatenations and to be able to use all of SQL's functions in this, we have this ability to be able to do row ID and row mod ID. So if I run that, you can see all the record IDs and how many times each of those records have been modified. So this $sign right here could be changed to a number sign. And what that's going to do is all these record IDs you notice that they're in quotes right here. So if I run it now that I have the number sign, it's going to change that string to a number. So the $sign is for anything you want wrapped in quotes, and the number sign, that's for any Boolean value that doesn't have any quotes, or for a number field. So that way it gets rid of the quotes around it. So any questions yet? I realize I kind of jumped right in. This went pretty fast.
I don't see anyone typing, but I'll take a moment to remind people to ask questions on all of the chats.
Okay.
I am watching them, so
Okay.
and don't be afraid to ask literally about anything related to subject today. So
Yeah. So for those of you who haven't downloaded the demo file, it is up in Discord. I believe it's on the other channels as well. So each week I come out with a new demo file, and each one of those you're going to want to download. The newest version is going to have the most stuff on it, because I continually update this each week. So I put a date on here. So today is December 20th. If it doesn't say December 20th on it, then you probably want to download the newer one. Because I added a lot of stuff over the weekend. So just want to make sure everybody gets the most out of these files. So counting the records in the table. So we're getting into a little bit more complex stuff. We'll go and colorize this. So we have table, contacts, SQL query. This is showing the old way, or the advanced way of doing it. And then I think this is, let me see what's going on here. Oh, it is JSON. Okay. SQL query, select count, format elements. Oh, okay, I see what I did. So this isn't used in the new functions. It's evaluating it a different way. It is using SQL query, select. Yeah, so I set this up a little bit differently just so that we can get the counting of records to work. So anyhow, so here I was just doing from one table, and here I was doing it for multiple tables. So if you needed to count records. Moving on. So here we got our JSON SQL select again. I didn't really explain what both of these are. This first one, that's your index field. So that's going to be your primary key. That's something you always want to keep unique. The second one we're going to get to a little bit later, but basically that's going to allow you to have a default JSON element within all of your blocks. So if I run this, I'll get to that a little bit later because that's a little confusing to try to explain. It's easier to show. Okay, so JSON SQL field. So here we're getting the contacts. Oh, querying specific fields. So basically, I've already shown you this. It's a little bit out of order. Sorry about that. I should have organized these a little bit better. So yeah, this is just showing ID contacts. So that's our primary key, and then our first name, last name. So again, if I didn't want this here, if I wanted to cut that out, I could easily remove this, and I can put it up here, and that could be our index field. And if I run it again, it's going to index, and it's going to show all the data for each of the records, just like that. Distinct function. So this is when this function first came out, it didn't have the distinct function. So I talked to Steve, Steve SSH, he goes by in the community. He's the guy that created all these functions. Really brilliant guy. So I've been friends with him for a while, and so he was really excited when I told him I was going to do this today and show off his functions. So this is one of the things that I helped bring into this function. So if we run this, it's going to only return 3,517 because it's looking for unique records where the first name and the last name are unique. So it's doing a distinct on both of these fields. If I were to include this, it would do all 5,000. So because it has a unique ID here, it's going to pull in everything because it can't have all three of these fields be, you can't have multiple values that are the exact same when you're pulling this in. So that's why I had that disabled. So if we remove that, you can see there's only 3,500 unique values of both first and last name. All right, concatenating with the select function. So just wanted to show that you can use this technique here to concatenate values. And if we run that, you can see our full name is our first name and our last name concatenated together with a little comma in between. I apologize for the spaces. That was part of a different demonstration. But basically, this is what we're trying to do. We're trying to bring David, add a comma and a space, and then Wood, and have it show up in our JSON as an individual field. So even if that field doesn't exist in your database, you can virtually create one on the fly like this. So using the double pipes as a separator, then we have our comma space in between the two fields. And again, you're always going to want to dynamically reference your fields. You don't want to just hard code your field name or your table name into these functions. So yeah, this is our data type variable, and this is our field variable. That's our source variable. So whenever you're using custom expressions, you want to be able to, you want to just make this empty, and then we want this to be our custom concatenated value. Not seeing any questions yet, so we'll continue moving forward. So the where function, I'll just colorize that. Okay, so we got our from and our where. So this basically repeats what we've been doing all along, where we're almost every ExecuteSQL call we make, it's going to have a where parameter in here, and that's going to help us identify what records we actually want. Because you don't want every single record most of the time. You usually just want to reference specific ones. So here we're doing where ID contacts equals 5110. And there we go. We got one record. So that's all we're asking for here. Okay, so working with dates and times. So again, this is kind of going over this again, that we have all of these where there is no data type specified, and that's going to give us our UTC timestamps, just like this. And then if we use JSON string, so it's kind of reiterating that using JSON string will convert this, so that way you don't have to use a coalesce trick using this technique. Space function. So yeah, this is going to just kind of show off again that you can use all of these different SQL functions within this, and you can concatenate and use, you can do all kinds of stuff. Even with JSON, you can do it. So, so here we have a very simple call that just gives us timestamp Boolean, timestamp number. So this is getting that same timestamp over and over and over in different formats. Just to show you different ways you can pull it in. And then here we're bringing in today's current day number, hour, minute, and so on. And then when the record was created. So it's, let me just pull this down. We're going to colorize this so it's a little bit easier to read now. So we got record created, and then a dot for our separator, and then timestamp SQL. So that's creating this record created, and then timestamp SQL. So I think all that makes sense to everyone. Don't want to spend too much time on that. But just wanted to show that you can do all those things and create JSON in the process. All right, so NumVal, that works pretty much the same as just adding JSON number on here. So here you can use an SQL function, NumVal, and you can get all these different values. And So here's using the NumVal function and what you get when you use that versus the actual values. How to give values between two dates. So a lot of this is kind of going over what we discussed the past few weeks. So we got between these two dates, or these two values, sorry. Normally I use this with date ranges. Works the same with date ranges and numbers. So basically we're getting values between these two numbers, and then it's showing, you can also use greater than equal to and less than and equal to, and that'll do the same thing. So here you can see both methods give you the same data. Using the lower and like operators. So if we run that, we're gonna it's gonna look for lower and then the name. So this is how you get around the case sensitivity issues, because everything in here is case sensitive. So this way it'll look at any of the values in here that are lower. It's going to just make this all lowercase, and it's going to compare it with lowercase values. So that way you get more results. If we didn't use the lower here, it wouldn't return any results because it's looking for a capital C, or we have a capital C and a lowercase o. So if these aren't both lowercase, then you're not going to get anything without that lower function first. So this allows us to get more results. All right, so using the in operator. So again, just like using the ExecuteSQL functions, we can also use that here because we're using it in this where section here. So we're looking at where the ID equals one of these three values. And so if we run that, we get records with those three values. Oh, and then again, it's looking for the name, and we're getting our response in JSON format, just like we wanted. So it's looking at all these different names. And it is sensitive to the data type. So when you're searching a text field, you want to make sure that you put apostrophes around it. So that way it knows it's looking for text inside of a text field. Up here, it's looking at a number field. And so therefore you want to look for numbers within a number field. Otherwise this won't work. So if I were to put apostrophes around this on both sides, just doing that's going to break the call. It's not going to work. So just, it's a little thing sometimes that gets you. So Ruben was mentioning that you can use select asterisks from table where. So you got to be careful with the asterisk function because that'll get you everything. So if we wanted to get everything, let me see if I haven't tried this, but we're just gonna see what happens if we do asterisk there. Okay, so yeah, it's good to try these things ahead of time. Yeah, it's a good question. How to use the asterisk here? Well, so it's best practices not to use the asterisk in here because it'll get you everything, and that could include summary fields or calculation fields or just undo. So yeah, you want to be able to control what data you're returning. If you use the asterisk, then you're going to get every field within the table, and then you end up getting unsorted calculation fields, summary fields, a lot of stuff that you don't want. Maybe those fields don't exist yet, but somewhere down the road, somebody might start adding unsorted calculation or summary fields to your table, and the moment they do that, it's going to kill your ExecuteSQL call. So it's best not to use that. So I never use that using creating JSON. I always specify what I want, and it gets me the data the way I want. See, I'm reading Ruben's comment here. You have in 146. You select statement inside the brackets. suppose you could do another ExecuteSQL call. I'm not sure what he's referring to there, but yeah, basically you want to create a list, and then the list needs to look like this in the end. And then it has to be, if you're searching in a text field, it has to have the asterisk on each side of the values. So that way it knows you're looking for text within the text field. So SQL is very sensitive about data types. All right, so moving on. Where function and the not operator. So not in. So this is just kind of showing another example of you can do the exact same call, but instead of getting these three values, you can get every value but those three by just simply putting the not operator before it. And so now you can see I'm getting everything after 5103. So it's omitting those three records and getting everything else. All right, so here, JSON Execute SQL, what are we doing? And or operators. So again, just like before, I was showing you can do this, and then you can do where, and it's doing a where ID context is greater than or equal to this value, and less than or equal to this value. So it's getting everything within that range, or it's going to get everything between this range. And we've commented in the past that you can also isolate this. So you can possibly avoid some issues between this section and this section. So you can put it's usually best to do that. Just keep things clean and easy. So that works great. It's not required here, but it does help you keep things straight between your different groupings. So here we're grouping this value to this value, and we're grouping that value to that value, and we're using an or as a separator between those two. Yeah, you can, I was looking at David's comments, you can nest different SQL statements within each other, and we'll get to that. So is null versus is not null. So basically, is null is going to look for any value where there is no value, and it's not null. And it does have to be written out just like this. You can't do not is null, even though this looks like is null, and normally you want to put not before whatever you have here. It doesn't work that way. You have to do is not null. So not is null doesn't work. So just kind of demonstrate that here. Not is null doesn't work. That's what happens. So a lot of times you do not, and then you get the opposite of what you're looking for, but that doesn't work in this case. You got to put is not null in that order in order for that to work. So here we're going to get all of our account, minimum, maximum, sum, and averages of this number field within this table, and we're going to group them by the field title. So for every record that has the title of empty, this is all your sums and averages. If your title is miss, this is all your sum and averages. And also notice I put the period here. So favorite number dot count, favorite number dot minimum. That's what's giving us this extra JSON object here. So it's grouping all the favorite numbers into this array here, or this object, I mean. So that's how we're doing that. So floor and ceiling, how do you get that to work? So floor, that's going to give us, that's going to essentially round down, and ceiling rounds up. In order to use that here, you have to use a custom expression. So we have our actual value of 2014, and when we're using ceiling on 2014, we're getting 25, and floor rounds down, we get 24. So that's how you can use that in this function. So make that a little cleaner. And we're just getting the one record here. Looks like there's another question. SQL statement is very sensitive to comma quotes. Okay. No, not really a question, more of a statement. All right. Moving on. So I actually like to keep a little space here. So these are all of our custom expressions. And here we're demonstrating how we can use trim here, ltrim and rtrim within this technique to get JSON. And so just like that, we can get our actual and our left trim, right trim, and so left trim, right trim, and then trim just trims both sides. So it's the same field over and over. So just kind of demonstrating the different trims you have. So we have spaces on both sides. With the L trim, we're trimming all the space off that left side. Right trim, we're trimming all the space on the right. And with trim, we're getting everything trimmed on both sides. So here I wanted to make sure that I captured this between the number and the dollar symbol. So again, we have our original value and our round and our square root. But the difference is here, we're getting this as a number. There's no quotes around it. And this one, we're getting into this a string with quotes around it because we're using the dollar symbol here. So dollar square root gives us text. Number round is giving us a number in our response. All right. So case function. So yes, you can use a case function here. And this is kind of demonstrating how we can do that. So we're doing it inside of a custom expression, and we're getting a string. So this is getting us a string response. And case when the number value is greater than 70, we want it to give us the text of above 70. When the number field is less than 50, we want it to give us a response of below 50. And if it doesn't equal either of those, then we want it to say between 50 and 70. So if we run that, we get our record ID, we get our message. So this is a message we're getting through the case statement. And then we have our number field. So we can see what the number actually is. So here we have our number field from our contacts number field. I'm not sure why we're getting a string. I think maybe I just wanted to show that you can get a string here. So we can just do this regular, and that should give us our number because that is a number field. And then custom expression is going to evaluate what this is. So instead of data type, again, we're using our custom expression, which allows us to do whatever calculation we want ahead of time, and we can pull it into our JSON array that or object that we're creating. Again, there's no source with this because our source is this function up here, our calculation. So yeah, you can also do a case down here through the order by function. I don't think we've gotten to that yet, but we will get to that. So here we got our lower and upper function. So we're selecting let SQL query. Oh, it looks like I'm doing this a couple different ways. Okay, I'm like, what is going on here? That's not going to give us JSON. So this is showing the advanced technique of just getting the SQL response and showing us what that's going to look like. And then we're doing the same call, but using the JSON technique where we're using our custom functions to get JSON in our response. I'm not sure why that's there. That doesn't need to be there because we're not using that parameter yet. So we'll show how to use that in a little bit. But here we're doing our custom expression. We're getting a text value, upper, and then name. So again, that's text. This is doing our function inside of our ExecuteSQL for upper first name, lower last name. And again, here's all of our text in upper, all of our text in lower. And then it's giving us our JSON array. So joins. Okay, so joins work a little bit differently when you're using this custom function. So I'm glad we're getting to this so you can see the difference. See, maybe I could probably show you what the join was, just to kind of refresh your memory. I'm going to just do a find join. Okay. So here in ExecuteSQL, we have join, and then we have the as function here, and on. So basically, divide this up. So we have join. So we're joining this table as, and then I, and then on. So then we have the C here to signify contacts. The I is for invoices. So just kind of refresh your memory on how a join normally works. And then if we return back to the JSON version, this is actually where I like using this function even better, because I don't have to even use join anywhere in this. So instead, we're referencing full name from our contacts. We're referencing the invoice total from our invoices table. And then we're getting data from our contacts table, and then using the comma here, and then we're mentioning our invoice table. And then here we have where, and you'll notice we're using a different function here. This is SQLTF, which is getting our contacts and our field name in one function with a dot separator between them. So where this contacts field equals this ID field in the other table. So this is actually our join right here. So a little bit different. I think this is a little bit simpler. And then I'll just run this so you can see it work. So here we have our full name and our invoice totals for Marjorie is 70, invoice total for Julia 26, and so on. So I'm going to go ahead and just, well, I can do that here. So if I take this out, let me just copy all of this and we'll put it in the data viewer. I think that'll be easier to rebuild this formula. Okay. So basically what we want to look at is what is going on here? What does this look like? Trying to comment that part out. Looks like that. And then what does this value look like? So as we showed you in the very first record at the start of this presentation, there's a lot of substitutions that go on. So this kind of wild looking, isn't it? Yeah, so it's doing all these substitutions inside of this here, and then it's using another function to be able to substitute all of this extra stuff here out for the actual text. So it's getting context name full. So yeah, this is what I wanted to show you right here. This is what the TF is giving us. That's our SQLTF. It's giving us the quote and then context dot name full. Then it's got some more concatenation here. So this JSON SQL select function is giving us all this stuff, and it's putting all these extra symbols in here, which is going to be substituted later when it goes to find the result of it. So yeah, so where it's doing from, contacts, invoices, where, and then there's all in quotes with the dot separator, where contacts ID context equals invoices ID contact. That's where our join is happening. So right here, it's using this function to create all that text. And then we have our result, JSON result is going to look at this, and then it's going to do all of the substitutions that it needs in order to be able to make it be able to evaluate this. In this ExecuteSQL, it's going to return pretty JSON. So it's doing all that work for us so that we don't have to do all of that. And then it returns JSON, which is great. Union. So again, union put this in here so that we can see a traditional way of doing this, or rather the advanced way of doing it, I mean. So we have basically two queries. We got this query, and then we got this query up here, and it's creating a union between those two in order to give us our response. And then it's ordering those the values in that response, first name, last name, both ascending. So we'll just see what that looks like. So here you can see it's putting it all together and it's sorting it all, which is great. So how do you do that with our new function? Again, I don't know why that's there. Okay, so using our JSON functions, we can do the same thing. And where are we doing? Right here. So this is where our union happens. So we can do this as many times as we want here. If I wanted to add more names into it, I can just copy, and we can add in, say, Christian, I don't know, Dave. Just some random names in there. Run it again. So there's that phone again. So here it's pulling in Christian and Dave. One thing I noticed is for some reason when you're using this method of union, this order by, because the order by is happening up here and the results is actually down here. So I actually do have a custom function that I've included in this file to solve this problem. So where it's not sorting this array, we can actually sort that. And yeah, does anybody have any questions yet? So I'm just gonna kind of jump through here, show you where that custom function is and how that works real quick. Did I pass it? Sort array. Okay, so this I kind of just wanted to show you that I did include this in here. And this will solve the sorting issue that we just saw. So basically what we're doing here is it's looking at this JSON, and we want to sort this array from this field. We want to sort it by the amount. It is a number. The amount is a numeric value. And then we want to sort it descending. So what that's doing is it's sorting the amount descending, giving us the largest numbers first. And then here we're going to do the same thing where we're getting that JSON, and that's giving us this part of kind of jumping into this. So this combining a couple different custom functions. This custom function basically takes the result from here, and then we're getting the first 5 values and truncating that out of the rest of the values. So it's returning only the first 5 values. So here we got some JSON here. And so this is what I really wanted to show you. This is actually sorting that same array, but 3 different ways and different directions. It's got text in here, it's got number values in here. So this allows us to sort by the last name, and it's not numeric, and we want to sort that ascending. Here again, the first name, not numeric, and it's ascending as well. So we have our last name and our first name, and then we have our amount in here, which is numeric, and we want to sort that descending so that we get the largest numbers first for each person. So here we have, I think, just Richard, Kyle, and Margs. So we're sorting by the last name first, so last name, then first name. So you can see Carlton is first, then Margs, and we scroll down, Richard's next, and then Nick Hunter, so H comes after C, and of course Nick, John Smith, and Williams is last. And again, it's pulling us all together, it's sorting it, and you see the largest amount is first, and so on. So that's my custom function in action. It does not use any plugins. It uses functions that are built into FileMaker, and it just takes advantage of the fact that FileMaker automatically sorts everything ascending, and it uses a custom function to reverse the text in order to get the descending result, which I believe, yeah, right here, it's basically using this to get our descending result. So it's looking at the text here, and then it's returning the opposite. So basically the inverse value of whatever text. That's how I'm able to get it to reverse the sort direction. So it's using FileMaker's function to automatically sort everything ascending, and then it's just reversing the text. So that way I don't have to sort anything. FileMaker sorts everything very quickly. So that way it sorts everything really fast. So we'll get into the custom functions later. So there's so many more custom functions in there. I just keep adding and adding to it. Did we have any questions yet? I've been just kind of rambling on here. FileMaker should not sort at all. It would be nice to have the ability to turn the sort on and off. I actually put that into the community forum that, yeah, I really wish there was one extra parameter that we can add in there, or maybe a new function that we could turn that on and off, because it is kind of annoying, especially when you start doing API integrations, specifically API integrations where everything is by default XML, but they offer us a JSON alternative. But the problem is JSON has to be out of sort order. So everything has to be in XML order in our JSON. So that's where that becomes really annoying. One prime example is Authorize.net. Everything in their engine is XML, and basically it takes our JSON object that we feed it and it converts it into XML for their engine, because it was built a long time ago before JSON was really popular. So they just tried to make it work with JSON, but still use the original engine. So they didn't want to rebuild everything. So in those cases, I really wish we could turn that off. All right, so here we have join, left join, right join, full join. Again, the right join and full join are not supported in FileMaker. And according to this URL, or this PDF here on page 10. So I did find the actual specifications why those aren't working. Only join and left join work in FileMaker. And that is because FileMaker, when they created their SQL engine, they wanted to keep it very simple. So instead of having a convert and a cast function, they just gave us the cast function. They kept everything as simple as possible. And of course, they only gave us a select statement. I really wish they would enable everything. But that's why we have MBS, and we'll get into MBS next time. A lot of really cool stuff I wanted to show you there. So here I wanted to show the join, the traditional method of using the actual join, and join as on that method. And then below that we have creating JSON, I think. No, that's, I didn't create JSON here. Okay, so it's because I'm into advanced. Okay. Sorry about that. So we're in JSON now. I'm like, why isn't that creating JSON? All right. So group by, yeah, I thought that was weird because we just covered union and join back here, and here I was going right back into join. I apologize for that little diversion. So yeah, here's our union. We just discussed union. So group by. All right, so group by, how does that work in the JSON function? You can see here we have group by, and we're grouping by the state. It works very much the same as the traditional method. So here we have our state, and then we have our aggregate functions, sum and average. When you group by, you have to reference all of the fields up here. So if you have multiple fields up here, they need to be grouped by all of those fields, otherwise it's going to break. It's kind of annoying, but it is what it is. So, all right, so let's go ahead and run this. So it's grouping by the state. We're getting Alabama, Arizona, California, and it's giving us the average and sum by each of those. So I was thinking, I haven't tried this yet, but I just want to try this for experimentation purposes. So what happens if we try to use this up here? This is our key, our unique. Hey, it still works. Nothing breaks. And that way we can say get JSON element or JSON get element AL, and we just want this object. We can do that. We can use the state as our unique identifier in this method. So you can see I commented out our state here and put it up here where our unique ID value goes, and it still was able to group everything and sort it all. So really cool. I was hoping that would work. I thought it would work, and it did. So awesome. All right, yeah, and this is showing the like. And again, it's using the lower like, and it's like CO. So nothing before the CO. Percentage after means anything or nothing can come after it. I think we covered this before, that you can also do an underscore here if you have one value before it, or percentage if you want anything before it. It's kind of the wrong example to demonstrate all that on, but maybe we can get to that in the next couple here. So this is adding the having function to our group by function. So the having only works when you're using group by. And so it's grouping by the state, but it's only giving us results where the sum of those states in this number field is greater than 200. So let's go ahead and run that. So our sum is greater than 200 in both of these, so it's working as expected. And then down here, we have our state, and then our aggregate functions here, group by. But here, instead of doing sum, we're doing the average, where the average is greater than 50. So down here, you can see average is greater than 50 on all of these. And yeah, so it's omitting anything that where the average is not greater than 50 and just giving us those results. So that could be relevant for doing reports or something where you only want the best of. So you want to get the best averages, and you want to see what states are doing the best, and you don't really care about the rest because they're all way down below or there's almost nothing to report on them. So that could be a good way to omit those records. All right, so moving on. So here, the exist function, this also works with, what was it? Any, all. There's a few others that also work here, and they're pretty much the same idea, and they all work a little bit differently. They're all variances here. So this is looking for any value within the select statement that exists, and if anything exists, then it'll show the values. If this doesn't result in anything, then it's not going to return anything. So here it's returning a bunch of stuff. So it's looking for the title. If the title is null anywhere in this table, like here we have the title is null here, it's null here, null here. So therefore it's returning a response. So if I were to say new record, in this record, I'm going to data, contacts, and here I have all the data. If I go over here and I just populate this with some random values, and I'm selecting the other records to commit those records, and then if I run it again, nothing shows up, and that's because those values are no longer null. It's looking for any results that have null. So basically, it's turning this on and off using the exist function. And then there's any, and I can't think of the other ones offhand. If I go into here, show all. Okay. So here we have the any function, the sum function. Okay. The any, sum, and all. Those are the other options here. And you can see it looks pretty much the same. So I didn't really bother adding those to the JSON part. You can kind of reference these to see what's going on. But any exact, any, sum, and all kind of work the same. It's the same formula each time. The only difference is what you're using right here. So going back to our JSON, order by. Okay, so this is where we have our sort function. It's not sort by, it's actually called order by. So in FileMaker, we do sort by. In SQL, it's got to be order by, and that it's got to be either descending with DESC or ascending with ASC, or it could just be empty. And empty is the same thing as ASC. So if you don't specify sort order, so you already take this out, this should still work, and it'll, oh, because it was descending, now it's ascending. So by default, it's ascending, unless we specify otherwise. Descending. There we go. Now it's descending. So that's how order by works, and it still works in our JSON functions. Pretty much the exact same. Here you can also use fetch and offset. I like to colorize the formula. It's so much easier to read. It's nice to have that ability here. So yeah, order by descending, ascending, descending first name, ascending last name. And we're just using fetch first 5 rows to get our first 5. Alternatively, we could comment this out, come down here, and bring this in. So now we're toggling this. We're getting the first 30% of the rows only. So I have no idea how many records that is. That depends on the size of the table. But you can see it gives us a lot more. So it's giving us 30% of the records in our JSON response. Okay, so moving on. Oh, so yeah, earlier I said we were going to demonstrate the second parameter. So let me go ahead and colorize that. So we have our first parameter, and that is our unique identifier or primary key. So if we want to have everything organized primary key first, that's what that one was. And this one is a template. So this is our JSON row template. So say we're putting this together, but we want this to happen on all the records. We want to say we want shipping instructions with a message, do not leave package. Do we want to require signature? We can have that up here. And maximum delivery times 3. So if we run that, what it's doing is it's adding this block in here. So this shows us how we can just dynamically add a section of JSON in our JSON response. So we have our address, our instructions, and our recipient, all of that information. So yeah, this is our shipping instructions. Here's our shipping recipient. And if I separate that, now you can see shipping address. So shipping.address.street, that's giving us our shipping, and then our address, and then .street, and so on. So that's what's, this is right here, is providing us with the shipping block, or shipping address. And then we have our shipping recipient and our template. It's kind of limited to the number of uses here, but it's there if we need it. If we decide, hey, if we want to add that extra JSON in there to have it be the same every time, that shows us how we can do that. So I'm not seeing any questions yet. So this is putting it all together. So I try to do this at the end of each section. So we have our let, and then here we're doing ExecuteSQL. We're getting these values, but I've also added a join in here. So we have invoices total and contacts last name. So we're getting from both these tables where this field equals that field. And then we're adding in the lower function. So basically what I'm trying to do here is I'm trying to put everything together in the order in which you would use them. So we have group by, having, and order by. This is great for a template. And then of course, I have several different unions here. So we could run that. And again, the union is kind of tricky here because it doesn't allow us to sort all of our JSON. And that's why I included the JSON sort function, custom function. So that should be it. And then I just have this here. I added this since the last presentation. So I'm just going to sort this or color that. So I just wanted to add a little warning in here that if you're going to use the asterisk symbol, it could spell trouble for you down the road. Say somebody down the road add some new summary and unsort calc fields to your table. They will, without even realizing it, they can kill the performance of your query because you use the asterisk symbol, because that's pulling in every field within your table. So the reason that doesn't really work with your JSON function is because when you're creating the JSON, you want every JSON to have a specific value. The reason that didn't work when I was trying it is because you have to specify what you want the field value to be, or your field key, I mean. So you have all the values, but you have to specify keys. That's why it wasn't working earlier when I was trying that. Realized that afterwards. It's like, oh yeah, you need a key for those field values. It's not going to come up with keys on its own. So that's why it doesn't work with the JSON functions very well, because we need to specify our keys here. So yeah, you can use it, but use it with extreme caution, because somebody down the road could start adding more fields. Those fields don't exist yet. While your function works great now, it might not work down the road, especially if you have 100,000 records in your table and you're trying to get every single record in your response. So yeah, this is basically covering things to avoid doing and things you can do to improve the performance. So you can think about utilizing perform script on server, so that way the server's doing all the stuff on its side and you're not having to do all the stuff on the client side. Keep your query simple. Find ways to avoid joining multiple tables together. The reason why you want to avoid that is because when you're doing an ExecuteSQL query, it's starting with a blank slate every time. It doesn't know what you're going to ask for. All it knows is you're about to perform a request. It has nothing at the start. It's building the relationship on the fly, and then it's going to try to give you a response at the end. So if it doesn't know what it's creating until you ask it what to create, these relationships can slow things down. If you do want to use that, maybe you want to try to use execute data API script step instead, because that way it's using FileMaker's already built relationships, and it's going to give you your related data faster. All right, so now it's time for Q&A.
I haven't seen anything beyond that one question from Ruben.
Yeah, okay. Ruben did mention container data. So when you're using the asterisk, it's not going to get container data. What it's going to get is your file names. So it's going to say random picture.jpg or random file name.pdf or excel.xlss. So it's going to give you the file name. It's not going to give you all of the base64 data from that container unless you actually specifically ask for that. So you can create a calculation field in order to get base64 data. It's not recommended to do that because that's going to hugely bloat your response. The larger your response is, the slower it's going to be for FileMaker to be able to parse all that out. So I would only do that if I was only going to get one or two records in my response, because it's just going to slow everything down. It's doable, but I don't recommend that. All right, on that note, does it get raw data out of containers? I think I just answered that. All right, so it is 2:24, so there's any further questions. Oh, so I did include Steve's file here. This is the newest version of his file. And so you can click on View Examples. There's 118 examples, so you can take your time and go through this. This is from the guy that actually created these functions. So I figured it's something you definitely want to go through on your own time. And, special thanks to me for helping out, and Jared. So yeah, as I said, I was helping him out with the seek function. So really cool to have that in here now. And so he demonstrates everything in here in great detail. If I were to go to table view, you can kind of see what he's got going on here. So different comments. So anyhow,
basically, the one comment from WJH I think is what most people have is great info, need time to try it out to discover questions to ask.
Yeah,
so
it's definitely something you want to play with. So I did put my email at the bottom if you have any questions. So if I go down here, there's my email right here. You can select on that. It'll send an email to me. So that's a great way to get a hold of me if you have any questions down the road. I've been using his functions for 4 years now. So I've had a lot of experience. I also included his 2 videos he created when he created these files. So this is really helpful information. The first video here, basically, it shows how he originally started creating JSON with the ExecuteSQL responses. Basically, it goes over what I did right here at the start, and he shows how he came across this and how he started building the function to begin with. And the second video actually explains all the custom functions here that I've shown today. So
okay. Awesome. Thank you so much, Kyle. This is awesome and very thorough, and I'm sure there'll be a lot of video rewatching to come in the future. Thank you so much, everyone, and thank you again, seriously.
Yeah.
Got a report of an individual up here who may be a FileMaker license. Well, it's potentially expired. Look at the back of that car right there. Looks like the FileMaker license has expired. Sir, I need you to step out of the vehicle. Sir, step out of the vehicle. Sir!